हो चालेल की, काय हरकत नाही. किती मुलं आहेत?
12.
12 आहेत का?
ते काय आहे, मुलांचे ऍडमिशन चालू आहेत ना, त्यामुळे
हा,
काल पण मुलं आली ना ऍडमिशनला आलेली आणि आज पण बऱ्यापैकी ऍडमिशनला आले त्यामुळे.
बरं बरं, काय ठीक नाही. आता 12 12th आहेत ना, 12 आहेत ना?
हा हा.
केलं 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 आले की आले ना.
हो. ते सर मी लिव्ह करते मग.
हा हा चालतंय, लिहा करा. ओके, काय हरकत नाही. शुभम आलाय का? शुभम आहे. हा, शुभम काळे आणि शुभम दोन आहेत शुभम आपल्याकडनं. ओके, गुड मॉर्निंग एव्हरीबडी. एम आय ऑडिबल?
Yes, sir.
Okay. Okay, good morning everybody. So as far as friends, just today we are going to touch with the actual the LIC papers and the unit number first, that is op-amp as a analog system blocks. So as per this op-amp analog system block is concerned, yesterday we have seen the op-amp, fundamentals of op-amp, block diagram of op-amp, parameters of the ideal op-amps and how they can obey the laws, and also we have seen the different symbol and the frequency response for the operational amplifier. But today this is I have taken the review of this one, that is the fundamentals of op-amp. In the last year we have studied this one. Now today we are going to see the unit number 1. Title is op-amp analog system building blocks, and as far this system block is concerned, this one. So in this topic, in this unit, we are going to see what are the linear and the non-linear system, that is analog system, that is linear analog system and the non-analog systems. So what is the concept of this one? Then afterwards we should go to join to the op-amp symbol and the ideal circuit model for this one, that is the equivalent circuit. Ideal circuit model means equivalent circuit of this one. What are the assumptions and implications related to the parameters of the operational amplifier, and how we are going to build the various applications as a inverting and non-inverting amplifiers. Before this, one more point is that actually we are going to learn what is the concept of the virtual ground, and it is a very most important concept while you are making some applications of the operational amplifier. And afterwards we are going to touch with to design and to develop the various analog applications of the operational amplifier in the various modes of the various configuration of the various areas, as a inverting amplifier, non-inverting amplifier, voltage amplifier, AC voltage follower circuit, summing amplifier, that is called the adder circuit, subtractor circuits, then log amplifier, anti-log amplifier, then integrator circuit, that is waveform generator circuits. We are going to build the waveform generator circuit as an integrator circuit, as a differentiator circuits. So these are the few applications we are going to design with the help of the operational amplifier by using the operational amplifier. So these are the some outline or the headlines of this particular topic, that is called the applications of the operational amplifiers, the analog system building blocks. But it is a very easy task, or it is a duty to design and develop these applications, but every student has to understand what is meant by the assumptions and implications and the concept of the virtual ground. Otherwise the students are unable to develop such types of applications, and then afterwards it is a very simple one. So as far this topic is concerned, that is the just I have shown here the op-amp symbol and the ideal circuit model is here. As far the symbol for the operational amplifier is concerned, it have two inputs, that is a V1 and a V2. That is V1 is called the non-inverting input, denoted by positive sign, plus sign, and another input, it is known as a V2 input, named as inverting inputs terminal and denoted by the minus signs. That means operational amplifier have two inputs, one or two outputs, then two terminals for the power supply is there. So this is the symbol for the operational amplifier, having a triangle, having in the base side there are two inputs are there, and at the corner, at the vertex side, there is the output phase 0. And what is the, in the below this, there is a equivalent circuit diagram for this one. That is called the ideal circuit model. What is in the ideal circuit model? We can look at this left side of this symbol. There are two inputs, V1 and V2, that is non-inverting input and inverting input. And just I have shown in the below figure, and that below figure shows that it is nothing but ideal circuit model. So in the ideal circuit model, second figure, we can focus on the left side. We can find that, we can observe that there are two inputs. That is a negative, that is a inverting input is there, it is a V1. Another input, that is a, okay. येते काय ऐकू शुभम?
हा ऐकू येते पण स्क्रीन दिसत नाहीये
नाही का स्क्रीन दिसत?
प्रेझेंटेशनची.
हा ओके ओके, वन मिनिट. ओके, शेअर झाली नसेल माझ्याकडून. ओके, 1 मिनिट. ओके, शेअर केलं, बरोबर आहे. प्रेझेंट के स्क्रीन के शेअर केलं. ओके, हा आहे का आता?
हो दिसते आता.
ओके, हा. Okay, just I will repeat again this one. This is nothing but a symbol for this operational amplifier having two inputs, V1 and V2, and V0 is output. And below this, there is a ideal circuit model for the operational amplifiers, or sometimes known as the equivalent circuit for the operational amplifier. You can look at this left side. There are two terminals, that is the inverting terminal minus sign, which are denoted by V1, and again the below line, that is parallel line, is a plus sign, that is called the non-inverting input, denoted by V2. And we can observe that there is no connectivity between the V1 and V2. That means these two terminals, V1 below terminal and V2 upper terminal, that is non-inverting and inverting terminal, there is no connectivity between this. That means they are open circuited. And if these are circuit, we can measure the resistance between these terminals with the help of the multimeter. We can see that, we can observe that there is no deflection in the multimeter. And if there is no deflection in the multimeter, points that the resistance between these two terminals is infinite. And that's why I have shown here input resistance, that is RMS resistance, and IN stands for input resistance. RN is equal to infinite. What I'm saying, RN is equal to infinite. Very shortly, we say that for the open circuit, the resistance is infinite, and therefore at the input side of the operational amplifier, ideal operational amplifier, the input resistance is RN equal to infinite. Okay, and that means these are the two inputs, and the net input is differential input, that is VD, and VD is equal to V1 minus V2. That is a difference of the two inputs, that is V1 minus V2 is known as a differential input denoted by VD, and that is applied between the two inputs. And as far as the resistance is measured, the resistance is measured between the V1 and V2 terminal, and both terminals are open circuited. There is no connectivity, and the concept is that the open circuit resistance is infinite, and that's why the input resistance of the operational amplifier is RN equal to infinite at the left side. Similarly, we can look at this equivalent circuit for the operational amplifier to the right side. We can observe that there is a source is there. The source is denoted by the circle and having the magnitude A into VD. A stands for the gain of the amplifier, operational amplifier, and VD is nothing but input, that is differential input of the operational amplifier. So it is nothing but voltage gain, it is nothing but it is a figure. Differential input, it is nothing but voltage, and therefore totally it is nothing but output voltage source. It is nothing but output voltage source, and in which we are connecting the output resistance to the output side. But for the ideal operational amplifier, the output resistance R0 is 0. What is meant by output resistance? Output resistance R0 is nothing but resistance which are measured between the output terminal and the ground. V0 is the output terminal, and we can measure the resistance between V0 and the ground with the help of the multimeter, with the help of the measuring devices, it is known as the output resistance. And for ideal operational amplifier, the output resistance is found to be R0 is equal to 0. So, and this is nothing but it is equivalent circuit. And the output voltage is measured V0 between the output across the output voltage source A into Vd, that is plus and the minus sign. So this is nothing but this is called as a ideal circuit model, or it is known as an equivalent circuit model. We can look at this one. Okay, we can look at this one. The input resistance. What is input resistance? Rin equal to infinite. That is called the assumptions. There are three assumptions which are related to the ideal operational amplifier or ideal circuit model. The first assumption is the input resistance Rin of the operational amplifier is infinite. What it indicates? What does it mean? A म्हणजे काय आहे? So it means that, or it implies that the no current will flows through the op amp or out of the op amp. We can look at this again, the figure, this one. V1 and V2 are the two inputs to the operational amplifier. Difference Vd is a differential input signal, and these two terminals are the open circuit, and that's why the input resistance is infinite. And if resistance is infinite, that means the opposing force is infinite. We can conclude that no current will be flows into the op amp or the out of the op amp. This is nothing but this is called the interpretation, or this is nothing but it is called the implications of Rin equal to infinity. Means the student has to learn that Rin equal to infinity, it is means that the input resistance of the operational amplifier is infinite, and that is known as a assumption. What is assumption? Assumption is Rin equal to infinite. And हे म्हणजे काय? The input resistance of the operational amplifier is infinite. What is the meaning of this one? What it tells? What it indicates? What will happen when Rin equal to infinity? When input resistance is infinite, at that time it will happen that no current will flow into the op amp or the out of op amp. म्हणजे याच्यातून करंट आतमध्ये जाणार नाही आणि बाहेर येणार नाही. This is known as an implication. म्हणजे assumption काय झालं? Rin equal to infinity. आणि त्याचं implication काय झालं? Input resistance infinite असल्यामुळं the current does not flow into the op amp or out of the op amp due to the infinite resistance. Infinite resistance चा अर्थ काय होतो? Infinite, the meaning of the infinite resistance is that there is a tremendous opposition is there, and that opposition cannot allow to flow the current into the op amp, the out of the op amp. And the resistance is nothing but it is a property of the material, and its property is to oppose the flow of current. And the infinite resistance means it does not allow the any type of the current into the op amp, out of the op amp. That means shortly we can try to remember that the Rin equal to infinite means it is assumption, and its meaning is that due to the infinite resistance, current does not flow into the op amp or out of the op amp. This is the implications, or this is nothing but this is the task when Rin equal to infinity. The second assumption is that output resistance Rin equal to infinity. We can look at this output side, and at the output circuit we can observe that R0 is equal to 0 for ideal operational amplifier, and R0 is equal to 0, it means that there is no opposition. Rin equal to 0 means the output resistance is 0, and output resistance 0 means there is no opposition at the output side. Whatever the power which are delivered from this source, this is a voltage source, this is the signal source, and the signal source supplies the power or the current to the output side, and that power which is delivered by this current source or the voltage source, that cannot be opposed by the resistance due to the zero resistance. Means entire current or entire power will be delivered to the load. That means its implication is that the output voltage source V0 does not change the load. Just suppose that we are connected here load, we can connect the some DC battery is there, DC motor is there, and just we can transferring the power to the load. And if the resistance R0 is 0 and we are supplying the power from this source to the load, the speed of the motor remains constant since R0 is equal to 0. But the output resistance has some values. It can change the value of this motor. That means the speed of the motor will be changed. That means, in shortly, I wish to say that when Rin equal to 0, input resistance, आउटपुट रेजिस्टन्स इनपुटच्या ऐवजी आउटपुट रेजिस्टन्स याला हे चुकून झालेलं आहे. आउटपुट रेजिस्टन्स इज इक्वल टू 0. दॅट मीन्स द output terminals or the output voltage V0 does not change the load, does not change the speed of the motor. If the load is motor, the speed of Hello. Hello. ऑडिबल आहे का? हॅलो दुमा.
येस सर.
कधीपासून ऐकू आलं नाही तुम्हाला?
5-10 मिनिटं झाले सर, आवाज ऐकू येत नव्हता.
5 मिनिटं म्हणजे तुम्हाला मी सांगतो, तर मी शेअर करतो. मला फक्त एवढं सांगा की शेअर केल्यानंतर एक मिनिट. हा ओके. हे झालं का तुम्हाला? हॅलो.
हा झालंय सर.
हे झालं ना? शुभम आलाय का? शुभम आता हे झालंय का? मला कुठपर्यंत आलं? हे ऐकलंय का सगळं?
हो झालंय सर.
हे लक्षात आलं का? थर्ड अजम्पशन्स वगैरे हे
सेकंड अजम्पशन सर एक्सप्लेन करत होता तुम्ही.
सेकंड का? हा मग ठीक आहे. हा मग थोडं बरोबर आहे. सेकंड अजम्पशन्स. ओके ओके. आय विल रिपीट. The second assumption is Rn equal to, that is sorry, R0 is equal to 0 means output resistance here R0 equal to 0. It means that the output resistance 0 means it indicates that the output voltage. You can look at this this side of this figure, this right side. The output voltage is V0, and when output resistance R0 is equal to 0, the output voltage does not change the load. Means whatever the power which are delivered from, this is a voltage source, and the voltage source is denoted by A into Vd. And this voltage source, the function of this voltage source is to transfer, to deliver the power from this source to the load, and the load is connected here in place of V0, instead of this V0, and whatever the power which are delivered from this source to the load, it does not change the load. Means we can connect the motor, DC motor आपण जोडली आपण, and we can transferring the power or the signal, delivering the power from the source to the load. The speed of motor remains constant. At what condition it remains constant? When output resistance R0 is equal to 0. But it exists some resistance in the output side. They can change or they can vary the speed of the motor, or there is changes in the speed of the motor. It will happen in shortly. So I wish to represent that, points out that the output resistance is 0. That means the output voltage does not change the load. So this is the second assumptions and the implication. And third assumption is that the open loop gain of operational amplifier is A equal to infinity. What is this? A equal to infinity? A equal to infinity means the open loop gain of the operational amplifier is infinite. That means the gain is infinite, and the open loop gain means what is this? There is no connection between the output and the input. It is called the open loop gain, and at the same time we can calculate the gain of the operational amplifier, that is a V0 divided by VI. That is a fundamental formula to calculate the gain of this operational amplifier. And in case of the operational amplifier, open loop gain operational amplifier, the input voltage is Vd, output voltage is V0, and we are calculating the gain. And gain of the operational amplifier in the open loop condition is that the A equal to V0 upon Vd. It is nothing but a gain. And we can transfer this A in the east side and Vd in this side. Therefore, the input voltage Vd is equal to V0 upon A. What is V1 minus V2? V1 minus V2 is nothing but, it is nothing but differential input. That is the difference of input. And Vd equal to V1 minus V2, V0 upon A. Here, the V0 means this is output voltage at the output side. It has some certain value, some finite value, at what condition? That when the gain of the operational amplifier is infinite, and that means A tends to infinity. And we can look at this equation. Vd is equal to V0 upon A. We can take the limit of this left side and limit of the output side. That is the limit of Vd as A tends to infinity is equal to limit of V0 upon A tends to infinity. And we can solve this limit of V0 upon A tends to infinity. The value of this limit will be 0. That means the final answer is that the Vd is equal to, when solve this one, the Vd, the limit of this left side is Vd is equal to, what is Vd? it is nothing but difference of two signal V1 minus V2. And what will be the value of this limit of this side? If the final value is 0, means the value of the limit is 0, and the final equation comes as Vd is equal to V1 minus V2 is equal to 0, or V1 is equal to V2. What it indicates, what it represents? It represents that the potential or the voltage at V1 terminal and V2 terminal are the same. They are the equipotential. They are at the same potential. They are the same nature. That means, so what is the status of V1? That will be the status of the V2. That means V1 equal to V2. And therefore, I say that when the gain A equal to infinity, the potential or the V1 and V2 at the same potential. They are at the same limit. एकाच limit मध्ये असेल. So again, I will recap this one. There are three assumptions and three implications. Out of this one, the first assumption is input resistance Rn equal to infinity. That means the current does not flow into the op amp or out of the op amp. Second assumption is output resistance R0 equal to 0. It indicates that the output voltage value does not change the load or does not change the so these are nothing but assumptions and the implications related to the ideal circuit model for operational amplifier. That is a small and decided. So you can try to remember that. Every student has to remember that the three assumptions and the meaning or concept of the three assumptions. That's we have to remember the implications of the three assumptions. It is a very important for designing the different types of the analog applications by using the operational amplifiers. So next we are going to see the inverting amplifier. Okay, Shubham, येते का आवाज? हॅलो,
ब्रेक होतोय सर आधी मध्ये.
रेंज कमी होती का?
हा.
एक मिनिट, आता ते फोन आला होता ना, आता एक फोन आला होता त्यांचा, त्याच्यामुळे कॉलेजही झाले असेल. ठीक आहे, आता येते.
शेवटचा पॉईंट रिपीट करता का तेवढा?
हो करतो. सांगा जाऊ. हा, शेवटचा पॉईंट कुठला? ओपन लूप गेन का?
हा तुम्ही समरी केली ना तीन ह्याची, तेवढं फक्त
समरी ना.
हा.
Okay, just I will recap up again this one. Every student has to remember that there are three assumptions. What are the three assumptions? Rn equal to infinity. First assumption, R0. R0 is equal to 0. Output resistance 0. Second assumptions, and A equal to infinity. Third assumption. And three assumptions have three implications or three meanings. So the first assumption is input resistance of the ideal operational amplifier is infinity. That means it does not allow any type of current which are flowing into the op amp or out of the op amp. So this is nothing but this is the implication or this is the meaning of Rn equal to infinity. Second assumption is that R0 is equal to 0. That means output resistance is equal to 0. It means that the output voltage does not change any type of the load, or it does not change the speed of DC motor. It does not change the parameters of the load. Third assumption is A equal to infinity, means the open loop gain is infinity. It means that it does not, it means that the two input terminals V1 and V2, they have a same nature, they are at the same potential, they have a same limit, they are on the same limit. म्हणजे V1 चं जे स्टेटस असेल तेच V2 स्टेटस असेल केव्हा? A equal to infinity. That means we can try to remember that three assumptions and the meaning of three assumptions or implications of the three assumptions. It is very important for designing the various analog applications or analog systems building block by using the operational amplifier. तर हे नसेल तर हे तुम्ही स्वतः तयार करून घ्या, हे महत्वाचं आहे. कारण मी दाखवलेलं आहे ते हे सिम्बॉल दाखवलेलं आहे आणि त्याचं इक्विव्हॅलंट सर्किट हे इनपुटचं इक्विव्हॅलंट सर्किट आहे आणि हे त्याचं आउटपुटचं इक्विव्हॅलंट सर्किट आहे. आणि याच्यावरनं मी तीन पॅरामीटर काढलेले आहेत. Rn equal to infinity, R0 equal to 0 and A equal to infinity. What is the meaning of this one? कारण it is so important for designing the various applications as inverting amplifier, non-inverting amplifiers, or a voltage follower, adder, subtractor, log, and any type of the amplification. तर याच्या ठिकाणी आपण याचा वापर आपण करणार आहोत. त्याच्यानंतर आलं लक्षात तुझ्या? हॅलो शुभम. ओके. आता आपला टायमिंग किती आहे? 1 आहे का 1:15 आहे? हॅलो
1:25 पर्यंत आहे टायमिंग.
बरं ठीक आहे. आता जस्ट एक पाहूया आपण आता थोडंसं आहे टायमिंग दिसतं आपल्याकडं. Okay, we can join to the inverting amplifier. So this is in this inverting amplifier, there is another one important concept is that we are going to learn the virtual ground. Virtual ground means it is imaginary. Ground, just we have heard the name ground. Ground, we can look at these right side figures. Okay, ground is nothing but denoted by such types of symbol. And ground, the concept or the meaning of ground is nothing but it is a point. Anywhere. And this ground means the ground is a point which can draw the infinite current and which have a 0 volt potential. This is concept of your ordinary ground. That means there are two types of ground: ordinary ground and next is a virtual ground. To understand what is the difference between the ordinary ground and the virtual ground, then the ordinary ground is nothing but it is the point which draws the infinite current from the any source and which have a 0 volt potential. त्याचं पोटेन्शियल लक्षात आलं. पोटेन्शियल डिफरन्स तर दोन पॉइंट मधलं जर व्होल्टेज मोजतो त्याला म्हणतात पोटेन्शियल डिफरन्स. द पोटेन्शियल डिफरन्स इज नथिंग बट इट इज अ व्होल्टेज which is measured between the 2 points. It is called the potential difference. And potential means it is nothing but voltage measured any point with respect to ground, it is the potential. So we can measure the potential at this point. We can found that it is 0 for the ordinary ground. आता घरामध्ये सुद्धा असतं, जस्ट वी हॅव अ इलेक्ट्रिसिटी कनेक्शन इन युअर होम अँड देर इज अ ग्राउंड पॉइंट इज देअर फॉर युअर इलेक्ट्रिफिकेशन इन युअर होम ॲट द आउटसाइड ऑफ द युअर बिल्डिंग. तर त्याच्यामध्ये तुमचं ग्राउंड केलेलं असतं आणि त्या ग्राउंडमध्ये काय कन्सेप्ट असतो की एक छोटा खड्डा खणलेला असतो. डिगिंग द एक छोटा खड्डा खणलेला असतो. त्याच्यामध्ये काय केलं असतं की कोल देन copper plate is built in this one. तर तशा आपला ग्राउंड पॉइंट केला जातो. That point is known as a ordinary ground point. And त्याचं सिग्निफिकन्स काय? What is the significance of the ordinary ground? The significance of the ordinary ground is which have a 0 volt potential and sinks म्हणतात त्याला किंवा draws a infinite current. And another point is that you can look at this upper side, that is nothing but junction of this one. This is a feedback is there. Okay, this is a feedback. This is a junction point of this R1, Ri and Rf. That is called the P1 point, and that P1 point is known as a virtual ground point. What is the concept of the virtual ground point? The concept of the virtual ground point is that which have a 0 volt potential, but it does not draw a current. But we can try to understand what is the difference between the ordinary ground and the virtual ground. So the virtual ground is nothing but it is a point anywhere in the circuit. This is a circuit, and P1 is a point in the circuit. And that means we are going to explaining the concept of the virtual ground. And the virtual ground is nothing but it is a point in the circuit which it does not draw any current, but which have a 0 volt potential. And similarity between the ordinary ground and the virtual ground is that both the ground have the 0 volt potential, but ordinary ground draws the infinite current and the virtual ground does not draw the current. We can look at this side. This is nothing but this is a operational amplifier. This is symbol for having a 2 input terminals. This is a plus sign, that means it's a non-inverting terminal. It is shorted to the ground, and through which the IB1 current, that means the base bias current IB1, it is called the base current IB1 is flowing towards the operational amplifier. And we can look at the second input terminal, that is called the inverting terminal. In this inverting terminal, IB2, that is the base bias current IB2 is flowing towards the operational amplifier, and the P1 is a point in conjunction with, or it is a junction point, which is a junction of the feedback resistors from output side to the input side, and again is junction of the input resistance Ri, and again the connectivity of the inverting terminal to this, means it is a junction point and denoted by P2, and that P2 is nothing but it is called the virtual ground. And the concept of this point is that we can measure the voltage at this point with respect to ground. We can find that it is a 0, means this P1 is another point. It is called the real ordinary ground which have the 0 volt potential. Similarly, the P2 is another point in the circuit. It is known as a virtual ground, and we can measure the voltage at the point P2 with respect to ground. It is found to be 0, or it is very much similar to that of P1. म्हणजे both V1 and V2 have a same potential, and that point is known as a virtual ground point, the virtual ground concept. We can try to understand what is the concept of virtual ground. The concept of the virtual ground is that the point is it is a point anywhere in the circuit which have a 0 volt potential, does not draw a current. That point is known as a virtual ground, and this virtual ground allow the similar voltage to that of V1. They are operated, and we can look at this one left side. Okay, this is circuit diagram for the non-inverting amplifier. Why it is called the inverting amplifier? Since this is an inverting terminal, it is a inverting terminal here, that is V, and the V is a voltage source which is applied to the inverting terminal via resistance Ri, and there is a feedback connectivity between the V0, so that amplifier is known as an inverting amplifier. Okay, we can try to understand that. Assume that is a VD is nothing but difference, that is differential input, and V0 is the output. How to calculate the gain of the amplifier? Generally ordinary amplifier. The gain of the ordinary amplifier can be say defined as, कसं define करता येईल आपल्याला? Output voltage V0 divided by input voltage Vi, and instead of Vi we have input voltage Vd, that is Vd is equal to, Vd is nothing but it is a difference of two voltages V1 minus V2, and according to our concept, that is when A equal to infinity, V1 minus V2 equal to 0, that means V1 is equal to V2. आता हे कसं काढलेलं आपण? I assume that Vd is equal to V1 minus V2, and I have shown that is equal to 0. Why it is 0? When the operational amplifier is ideal operational amplifier, it is operating in the open loop condition, the gain is infinite, and if the gain is infinite, A equal to A tends to infinite असेल तर काय असतं, the differential input signal is equal to 0. That means V1 minus V2 equal to 0. That means V1 equal to V2 equal to 0. And we can say that V1 and V2 are at the same potential. As far as non-inverting terminal is grounded, this is the plus sign, that is non-inverting terminal. That non-inverting terminal is connected to the ground, and ground is nothing but it is a point which have a 0 volt potential. That means V1 equal to 0 and V2 is a virtual ground असेल तर V1 equal to V2 असेल, and V1 equal to 0 आहे, that means V1 means non-inverting terminal connected to 0. V1 equal to 0 आहे, that means V1 equal to V2 equal to 0. So this is nothing but concept of the virtual ground. Then we can apply the KCL. KCL means Kirchhoff's current law. What is Kirchhoff's current law? Current entering at the junction is equal to current leaving out the junction. Which is a junction? The V2 is a junction. We can look at this. V2 is a junction. Current is I1 is this is a current. Okay, the I1 is current which are flowing towards this one junction point through Ri. IB2 is a current flowing out of the junction towards the operational amplifier. Then IF means feedback current. Feedback current means IF is flowing through the feedback resistor towards out. म्हणजे हा V2 point आहे. V2 point पासून IF हा बाहेर जातो आहे. That means we can observe that there are one incoming current, that is I1 is incoming current towards the V2. There are two outgoing currents, IB2 is towards the operational amplifier, and IF is a feedback current flowing towards the output side. One is incoming current, two are the output going current, and V2 is a junction point, and the KCL law states that incoming current is equal to outgoing current. That is algebraic sum of the input current is equal to outgoing current. Sum of the current at the junction, sum of current at the junction is 0. Or in other words, we can say that incoming current is equal to outgoing current. The incoming current is I1 is equal to outgoing current का है IB2 plus IF. Just I have shown here. That is I1 is the current which are flowing through the resistance Ri, which is equal to IB2 plus IF. IB2 is a current flowing into the op-amp of the inverting amplifier, and IF is called the feedback current which are flowing through the feedback resistance RF. These are two outgoing current, and these are the incoming current, and the KCL stands for incoming current is equal to outgoing currents, or net current at the junction is 0. Algebraic sum of net current at the junction is 0. These are the two ways to state. Okay. We can say that this is ideal operational amplifier, and being the ideal operational amplifier, Ri equal to infinity, input resistance is equal to infinity. It means that it means that current does not flow into the op-amp out of the op-amp. This is the symbol for the operational amplifier. IB2 is current flowing into the op-amp. IB1 is a current flowing into the op-amp. Okay. And according to our logic, that is assumption, Ri equal to infinity, input resistance of ideal operational amplifier. And जर असं असेल तर काय होतंय, implication काय येतंय, current does not flow into the op-amp or out of the op-amp, and that means we have to able to write the equation IB1, it is the base current, I is equal to IB2, second base current is equal to average current IB, which is equal to 0. That means the current does not flow into the op-amp or out of the op-amp. Current does not flow means the current is 0. Therefore, this IB1 and IB2 have the value 0. Okay, we can insert this value. This is the equation number 1, 2, and 3. We can insert the value in this equation. I1 is equal to IB2 is equal to IF, input current is equal to, and IB1 equal to IB2 equal to IB equal to 0. We can put up the value here. Then I1 is equal to IF. Means incoming current I1 is equal to outgoing current IF. म्हणजे input current I1 and feedback current IF. Then we can calculate the current value I1. इथं पहा, लक्षात घ्या. शुभम येत ऐकू?
हो सर.
Have any doubts or difficulties? काय आहे का त्याच्यामध्ये वरच्यामध्ये?
नाही सर.
नाही ना, काय अडचण असेल तर विचारा मला. तसं त्याच्याबद्दल काय, फक्त आपण केसीएल वापरलेला ह्या पॉइंटला. पॉइंट लक्षात आला का कुठला? हा V2 आणि V2 ला आपण काय म्हटलेला? इट इज अ व्हर्च्युअल ग्राउंड म्हटलेलं. आणि व्हॉट इज व्हर्च्युअल ग्राउंड? करंट एंटरिंग व्हर्च्युअल ग्राउंड म्हणजे इट इज अ पॉइंट एनिवेअर इन द सर्किट विच हॅव अ 0 व्होल्ट पोटेन्शियल. इथलं व्होल्टेज किती असतं? 0 असतं विथ रिस्पेक्ट टू ग्राउंड. आणि हा दुसरा पॉइंट आहे नॉन इन्व्हर्टिंग. तो कुठे जोडलेला आपण? नॉन इन्व्हर्टिंग टर्मिनल ग्राउंडला जोडलेला आहे. आणि ग्राउंड हा कसला आहे? ऑर्डिनरी ग्राउंड. ह्याला काय व्हायचं? ऑर्डिनरी ग्राउंड. आता ह्या ऑर्डिनरी ग्राउंड मध्ये काय फरक आहे? ऑर्डिनरी ग्राउंड म्हणजे काय? ऑर्डिनरी ग्राउंड इज अ
पोटेन्शियल आहे त्याचा.
हॅव 0 व्होल्ट पोटेन्शियल अँड ड्रॉज अ करंट. आणि हा पॉइंट कसला आहे? व्हर्च्युअल ग्राउंड. आणि व्हर्च्युअल ग्राउंड म्हणजे काय की व्हर्च्युअल ग्राउंड हा कुठेही सर्किटमध्ये असू शकतो, फक्त त्याला हॅव 0 व्होल्ट पोटेन्शियल आणि तो करंट घेत बी नाही आणि देत बी नाही, त्याला आपण व्हर्च्युअल ग्राउंड म्हणतो. हा त्यातला फरक आहे. आणि याच्यामध्ये आपण या जो पॉइंट आहे हा व्हर्च्युअल ग्राउंड पॉइंट आहे. हा इंटरजंक्शन ऑफ 3 ब्रांचेस आहे. आणि हा जंक्शन पॉइंट आला. आणि या जंक्शन पॉइंटला काय आपल्याला वापरला? केसीएल वापरला. करंट एंटरिंग ऍट द जंक्शन इज इक्वल टू करंट लिव्हिंग आउट द जंक्शन. करंट ऍट द एंटरिंग ऍट द जंक्शन काय आहे? व्हॉट इज दिस वन? I1 इज अ करंट ऍट द जंक्शन. करंट लिव्हिंग आउट द जंक्शन काय? IB2 आणि IF. म्हणजेच आपण किर्चॉफ वापरून आपण काय केलं? I1 इज इक्वल टू IB2 प्लस IF केला. करंट एंटरिंग ऍट द जंक्शन I1 इज इक्वल टू करंट लिव्हिंग आउट द जंक्शन IB2 प्लस IF. IB2 कुठं? ऑप-एम्प कडे जातो आणि IF कुठे जातो? फीडबॅक मधनं. असा फीडबॅक मध्ये पुढे जातो. त्याच्यानंतर आपण कन्सेप्ट दुसरा काय आपला अझम्पशन काय वापरलं? If the operational amplifier is ideal operational amplifier, and if it is ideal operational amplifier, its input resistance Ri equal to infinity. आणि इन्फिनिटी असेल तर काय अर्थ होतो त्याचं? इम्प्लिकेशन काय येतं? करंट डज नॉट फ्लो इनटू द ऑप-एम्प और आउट ऑफ द, म्हणजे बोथ टर्मिनल्स आर द ओपन सर्किटेड. आणि ओपन सर्किट असेल तर त्याचा रेजिस्टन्स इन्फानाइट असतो. आणि इन्फानाइट असेल तर त्याच्यातनं करंट वाहत नाही. आणि करंट वाहत नाही याचा अर्थ काय झाला की याचा अर्थ तो IB1 इक्वल टू IB2 इक्वल टू IB इक्वल टू 0 झाला. म्हणजे करंट इज 0 झाला. करंट डज नॉट फ्लो. करंट डज नॉट फ्लो मीन्स द व्हॅल्यू ऑफ द करंट इज 0. म्हणजेच काय झाला? IB2 इक्वल टू 0 झाला. म्हणजेच IB2 इक्वल टू IB1 इक्वल टू IB. कारण दोन्ही करंट सारखेच आहेत. दोन्ही कारण V1 इक्वल टू V2 आहे आपला. इथे लिहिलेलं आपण V1 इक्वल टू V2. मग V2 किती आहे? V2 V1 डायरेक्टली डाऊन केलेला आहे. म्हणजे याचा अर्थ काय झाला? 0 झाला. म्हणजेच IB1 इक्वल टू IB2 इक्वल टू IB इक्वल टू 0 झाला. मग ही जी व्हॅल्यू जी आहे आपण याच्यामध्ये IB2 ची व्हॅल्यू किती ठेवली? आपण 0 ठेवली. का ठेवली? या अझम्पशन आणि इम्प्लिकेशन मध्ये 0 ठेवली. आणि फायनल इक्वेशन काय आलं? I1 इज इक्वल टू IF. म्हणजे करंट एंटरिंग इक्वल टू I1 इज इक्वल टू current outgoing IF, that is current flowing through the feedback, that is, and just we can calculate the value of I1 and IF. आता करंट कसा कॅल्क्युलेट करतो? ओम्स लॉ प्रमाणे. ओम्स लॉ काय आहे शुभम? P इज इक्वल टू IR. बरोबर आहे का? बरोबर आहे. V इज इक्वल टू IR आहे आणि I इज इक्वल टू V अपॉन R आला. बरोबर आहे. त्याच्यानंतर आपण आता I1 करीत असताना मग हा करंट कसा काढायचा? इथला करंट हा जो I1 आहे तो कसा काढायचा? I1 इज अ करंट विच आर फ्लोइंग फ्रॉम इनपुट सिग्नल VI. इथं काय दिलेलं आहे? इथं बघा VI आहे. VI द करंट फ्लोज फ्रॉम VI फ्रॉम सोर्स VI टुवर्ड्स दिस वन. V2 कडे जातो. म्हणजे दोन पॉईंट आले. VI इज अ वन पॉईंट आणि V2 इज अनदर पॉईंट. आणि ह्या ब्रँच मधनं I1 करंट RI मधनं वाहतो. Ri is the input resistance, I1 is the input current which are flowing from input source Vi. Input source कुठला हा काय नाव आहे Vi towards the terminal V2. V2 is a junction point. म्हणजे करंट कुठनं Vi कडून V2 कडे वाहतो थ्रू Ri आणि करंटची व्हॅल्यू काय आहे I1 आहे आणि ती I1 ची व्हॅल्यू आपल्याला काय करायची आहे कॅल्क्युलेट करायची आहे. मग I1 ची व्हॅल्यू कॅल्क्युलेट करत असताना करंटचं इक्वेशन काय आहे V अपॉन R. What is V? V is nothing but potential difference between the 2 points. आता potential difference कसा काढायचा? Vi is the one point and V2 is another point. And Vi is the higher potential and V2 is a lower potential. म्हणजे करंट कसा वाहतो? हायर पोटेन्शियल कडून लोअर पोटेन्शियल कडे वाहतो. म्हणजे करंट फ्लोज फ्रॉम Vi टू V2. म्हणून द पोटेन्शियल डिफरन्स काय आला? V is nothing but potential difference. Vi minus V2. This is nothing but potential difference between the 2 points. The Vi is the first point, V2 is the second point, and therefore the current flows from higher potential to the lower potential. म्हणजेच पाणी हायर लेवल टू लोअर वाहतं. तसंच करंट हायर लेवल टू लोअर लेवल कडे वाहतो. म्हणून Vi मायनस V2 घेतलेला आहे. आणि म्हणून मी V2 मायनस Vi घेतलेला नाहीये. काय घेतलेलं आपण? Vi minus V2 घेतलेला आहे. म्हणजे Vi minus V2 is nothing but potential difference between the 2 points divided by resistance between the 2 points. Resistance between the 2 points म्हणजे Vi आणि V2 मधला रेजिस्टन्स काय आहे? Ri आहे. म्हणून the value of current I equal to V1 minus V2 divided by Ri. So this is the value of the current I1. Similarly, we can calculate the value of feedback current, that is If, which are flowing from V2 point to the V0 point. But we can try to understand. V2 is a virtual ground point and the current flows from V2 to V0. That current is known as a feedback current If, which are flowing through the feedback resistance Rf. हा रेजिस्टन्स आहे आणि तो रेजिस्टन्स कुठे जोडलेला आहे? आउटपुट आणि इनपुट मध्ये जोडलेला आहे. त्याला म्हणायचं फीडबॅक रेजिस्टन्स म्हणतात. कारण आउटपुट इज कनेक्टेड टू द इनपुट सो दॅट path is known as a feedback path, and whatever the resistance which are connected in the feedback path, that is known as a feedback resistance, that is a V0. And this If current, feedback current, flows from V2 point to the V0 point through the feedback resistance Rf मध्ये आपण वाहतो. And therefore we are able to calculate the feedback current which are flowing from V2 to V0 according to Ohm's equation. Current I is equal to V upon R. V is nothing but potential difference between the 2 points. हा V कसा कॅल्क्युलेट करतो? नेट व्होल्टेज बिटवीन द 2 पॉइंट. दॅट इज करंट कुठनं वाहतो आता? V2 पासून V0 कडे वाहतो. म्हणजे V2 minus V0, it is a net potential difference between the part divided by resistance between the 2 points, that is Rf. Therefore V2 minus V0 divided by Rf, it is the value of the current If. So in this way we can able to calculate the current I1 and If by this way. V1 minus V2 upon Ri is the value of current I1. V2 minus V0 divided by Rf, it is the value of the current, that is called the feedback current. We can put up this value, okay, and as V1, it is a non-inverting terminal, it is connected to the ground, and ground is nothing but it is a point which have the 0 volt potential. V1 have the 0 volt potential, means V2 have a 0 volt potential. Why? Since V2 is a virtual ground point, and if it is virtual ground point, and according to the concept, that is V1 equal to V2 equal to 0, and V1 terminal is connected to the ground, that means it has 0 volt potential. V1 is 0, therefore V2 is 0, and therefore we can put up the value of here V2 equal to 0. या इक्वेशन मध्ये V2 ची किंमत 0 ठेवायची. जिथे जिथे V2 तिथे द्यायचं आहे. आणि फायनली we are getting that Vi, इथे V2 ची किंमत 0 ठेवली की we get the Vi divided by Ri is equal to, इथे V2 ची किंमत 0 ठेवली म्हणजेच काय झालं? minus V0 divided by Rf. And then we can calculate the closed loop gain for this operational amplifier. Therefore closed loop gain is equal to, गेनचं इक्वेशन काय असतं? आउटपुट व्होल्टेज बाय इनपुट व्होल्टेज. आउटपुट व्होल्टेज काय इथं? V0, इनपुट व्होल्टेज काय? Vi. Therefore closed loop gain is equal to V0 divided by Vi, which is equal to minus Rf upon Ri. हे अरेंज करा. काय करा तुम्ही? जे Rf इकडे द्या, Vi इकडे द्या, मायनस साइन द्या. म्हणजे V0 divided by Vi is equal to minus Rf upon Ri. It is nothing but it is a gain of the inverting amplifier. It is a gain of the inverting amplifier, and just I have denoted as a ACL. Why? ACL. A is gain, CL stands for closed loop. Since there is a feedback, between the output and input. There is a closed system between the output and input. So the gain of that inverting amplifier is denoted by closed loop gain ACL is equal to V0 divided by Vi is equal to minus Rf upon Ri. It is nothing but it is the equation of the gain of this one. That is also we can calculate the input resistance. Input resistance सुद्धा ह्याच्यावरून आपण काढू शकतो. Rin is equal to Vi upon I1 is equal to R1 ह्या गोष्टी त्याच्यामध्ये काढू शकतो. This is all about the gain of the inverting amplifier or the concept of the virtual ground. First point is शुभम ऐकू येतंय?
हो सर.
तर this is nothing but concept of the virtual ground, difference between the ordinary ground and the virtual ground, and equation of the inverting amplifier or the equation for the gain of the inverting amplifier, that is ACL is equal to minus Rf upon Ri. What it indicates, how we can conclude that? We can look at this equation ACL equal to minus Rf upon Ri. There are three, we can conclude that from this equation we can make the concluding remark that the gain is a negative, but gain never is negative. But why it is negative? It is operated in the inverting mode, so that is gain is negative. Minus sign indicates that the minus sign indicates that the input signal Vi and the output signal Vjo, they are 180 degree out of phase. Minus sign काय दाखवतं की the sine wave अशी आपण दिली की इथं आउटपुटला आपल्याला सायनस वेव्ह मिळणार आहे एम्प्लिफाईड, पण कशी मिळणार आहे? फेज डिफरन्स असलेली उलटी मिळणार आहे. म्हणून that is called the inversion between the input and output. This is the meaning of the minus sign, and we are able to calculate that the gain. We are able to determine that you are able to set the gain of the inverting amplifier by selecting the factor Rf upon Ri, or by selecting the component feedback resistance and input resistance. This one. So this is nothing but this is the some concluding remarks from the equation of the gain of the closed loop gain of the inverting amplifier, that is ACL is equal to P0 divided by Pi is equal to minus Rf upon Ri. So this is nothing but this is the equation for inverting amplifier. This is all about the inverting amplifier, concept of the virtual ground and the ordinary ground. याच्यामध्ये एवढं आपण आज पाहिलेलं आहे. Tomorrow just will touch with the other type of the amplifier, that is called the non-inverting amplifier, by the use of the two laws, KCL and the KVL laws, voltage divider rule, current divider rule, and some assumptions and implications. Three assumptions and implications. By implementing this one, we are able to design different types of the amplifier circuit, the operational amplifier circuit, that is non-inverting operational amplifier किंवा analog circuit आपण डिझाइन करू शकतो. ओके, काय त्याच्यामध्ये आहे का? त्याच्यामध्ये काय अडचण आहे का शुभम?
नाही सर, समजले सगळं.
समजलं का? नसेल तर आपण परत रिपीट करूया. नोट्स वाचा तुम्ही. परत कधी कॉलेजला तुम्ही आम्ही बोलवणार आहोत त्यावेळेस जर तुम्ही आला नोट्स घेऊन किंवा मी ठेवणार आहे तुम्हाला ई नोट्स ठेवणार आहे, त्याच्यामध्ये तुम्ही प्रिंटआउट काढा किंवा तुम्ही ऑनलाईन तसे वाचू शकता. माझा गुगल क्लासरूम आहे, त्या गुगल क्लासरूम मध्ये मी त्या नोट्स काय केलेल्या अपडेट केलेल्या आहेत, किंवा काही दिवसानंतर पुढच्या आठवड्यामध्ये आपल्या एखादा व्हॉट्सअपचा ग्रुप आपण करणार आहोत आणि त्या व्हॉट्सअपच्या ग्रुपला आपण काय करणार आहोत, थोडंसं मी केल्यानंतर त्याला सुद्धा तुम्हाला काय गोष्टी शेअर करेल. त्याच्यामध्ये ई नोट्स असतील, ही असतील, आणि माझा गुगल क्लासरूम आहे आणि गुगल क्लासरूम मध्ये सुद्धा ई नोट्स असतील, MCQ असतील, काय अपलोड केलेल्या गोष्टी असतील तर ते सुद्धा तुम्हाला पाहू शकता. त्याचा ऍक्सेस मी तुम्हाला देणार आहे त्याच्यामध्ये, किंवा सर्वच विषयाचा. माझाच असं नाहीये की जेवढे तुम्ही 4 विषय शिकणार आहात किंवा स्किल एनहान्समेंट कंपल्सरी कोर्स शिकणार आहे, AECC शिकणार आहे, त्या सर्वांचे क्लासेस त्याच्यामध्ये असणार आहे. आणि तुमचं याच्याच बरोबर फ्रायडे आणि सॅटर्डेला तुमचा ॲडव्हान्स डिप्लोमा कोर्स असेल तर तो ॲडव्हान्स डिप्लोमा कोर्स सुद्धा चालू होणार आहे. त्याच्यासाठी ते सुद्धा तुम्ही लेक्चरला त्याच्यामध्ये सामील व्हायचं. मी जर थोडंसं बाहेर येतो याच्या, जेणेकरून आपल्याला हे करता येईल त्याच्यामध्ये. तर मी आलो आहे मेन फेजला, त्याच्यामध्ये आलेलो आहे.